So we're going to continue in chapter 6, and we're going to slow it down a little bit and start looking at ratios and how they're related to rational numbers. A ratio is a comparison of a quantity, which I could write either as a fraction or as A colon B, so A to B. And that's going to be used to represent a part to a part to a whole, or a whole to a part comparison. So here's an example. There were 7 males and 12 females in the Dewdrop Inn on Monday evening. In the game room, there were 14 males and 24 females. Let's work on expressing these as a ratio. So if I'm looking at the ratio of males to females, that would be 7 to 12, which I could write as a fraction for part to part, 7 over 12. If I want to represent it as a number of males to females that I'm looking at in the game room, I have 14 to 24, but that does reduce to 7 over 12. If you enter 14 over 24 in the lab, it's going to say incorrect. You have to reduce it. Now, if I want to express the number of males in the game room to the number of people in the game room, that would be 14 males, and then I would say 14 plus 24 is 38, or that's going to reduce to 7 over 19. A proportion, then, is going to be defined as a statement that gives two given ratios that are equal. So I have one fraction equals another fraction, and that's true only if when I cross multiply, I get an equal statement. So here I have two people going at the same speed. When I start comparing their speeds, I have an additive relationship. So we should realize that the two people type at the same speed, but someone has typed an additional 6 pages, which means if they're the same speed, there should be have also done 6 additional pages. If Carl types 8 pages for every 4 that Dan does, and Carl typed 12 pages, or Dan typed 12 pages, how many did Carl type? Well, this is a multiplicative relationship. Since Carl is basically typing twice as quickly as Dan, then I would be able to say 24 pages. Notice I'm not really setting up a proportion. I'm not really solving it because these are kind of mental math. Here is where it gets a little bit different. If I have cars to students, that's going to be 3/8. How many cars are there for 1,200 students? That's not quite as simple as doubling something. So I'm going to set up a proportion. I'm going to cross multiply. So 3 times 1,200, 8 times x, and then I'll divide both sides by 8 to get 450 cars. Now, a constant of proportionality means that I'm taking that proportion and multiplying it by a constant number. So the central idea here is that in proportional reasoning is that there's a relationship between two quantities, which is going to remain unchanged as the numerical values of the quantity change. So the ratio is kind of going to remain the same. So an example of this is using a scaling strategy. If I want to compare two purchase price points between maybe something that's on sale and something that's not, I want to break it down into the simplest unit. So a scaling strategy for solving a problem would involve finding the cost of a common number of tickets or the least common multiple. So I get 60. In the first plan, 12 tickets would cost $15, then 60 would be 75. In the second plan, 20 tickets cost 23, then 60 would cost 69. So the second plan is the better buy. If I want to use a unit rate strategy, then I'm going to use that to find a unit rate. So that means per unit, so per one. In the first plan, since 12 tickets cost $15, I'm going to do 12 divided by 15, and I get $1.25, or 15 divided by 12, and it gives me $1.25 a ticket. I do the same thing in the second plan, and look, I find the same answer. The second plan is the better buy because the per unit price is better. So when you're shopping at, say, Sam's or Costco versus the grocery store, this is always the thing you have to look at because sometimes buying in bulk is not always your best option. In this example, I want to let X be the unit rate, and in this case, the unit rate being the pay per hour, so per singular hour. Then 30X is going to be the amount of money that Kai received. If I have the other person receiving 50X, and then I'm looking at, will the ratios be the same as 30 to 50 as required? If I'm looking at this, well, The total amount of money I'm getting is the 30 and the 50 and the 60 combined from the three people. I combine those out to be 140. I divide both sides by 140 to get 18. So I know that Kai gets 30 times 18, which is 540. I know that Paulus gets 50 times 18, which is 900. Therefore, Judy gets 1,080, and they get a proportional pay based on the rates that they're being paid. So I also can flip my proportions, and they should still be equivalent, so that I know that when I have A over C equals B over D, I'm basically looking at different ways to cross multiply those values. Now, a scale drawing is often used in maps, not as often today because we don't use a ton of maps, but when we're looking at pixels on our screen, we are looking at a scale or a specific ratio. So when I'm looking at floor plans, it's the same idea that even though the floor plan or the image is smaller, it should be proportional to the real image. So to find this, I'm going to use the scale of 1 to 300 to represent those dimensions. So then 3.7 centimeters is going to be multiplied by 3 to get 11.1. And then 2.5 is going to be multiplied by 3 to get 7.5 meters. So the dimensions then would be 11.1 meters by 7.5 meters.